In a world powered by electricity and machines, the Amish do things differently, using nothing but skill, tradition, and pure muscle. From building sturdy barns to crafting furniture that lasts generations, their methods might seem old-fashioned, but they work better than you'd think. These 25 Genius Amish Building Hacks prove you don't need power tools to get powerful results. Charcoal smoke preservation. The Amish preserve wood using charcoal smoke instead of chemicals. Wood is placed in smoke chambers at 110 to 140 degrees Fahrenheit for weeks, allowing smoke to penetrate deeply. The process must be carefully controlled. Too much heat causes cracks, too little fails to protect. Proper smoking bonds smoke compounds to the wood fibers, making it resistant to insects and decay. The treated wood darkens and can last for decades, with some smoke-preserved structures staying intact for over 200 years. Two-person crosscut sawing. Amish loggers fell trees using long, 6 to 8 feet crosscut saws operated by two people in perfect rhythm. Each pulls alternately to keep the saw moving smoothly, with one setting the pace and direction. Proper sharpening and tooth setting are key for clean, safe cuts. With skill and coordination, Amish teams can fell trees up to 4 feet wide with accuracy, guiding them to fall exactly where planned. Friction heat sharpening. The Amish sharpen metal tools using friction from grinding against natural stones, without electricity. Coarse stones fix damage, while finer grits create sharp, polished edges. Friction can produce heat up to 400 to 500 degrees Fahrenheit, so craftsmen cool tools in water to prevent overheating and preserve the metal's temper. This method often results in sharper edges than factory-made ones through careful control and skilled technique. Horse-drawn timber skidding. Amish loggers use teams of draft horses to move felled trees without damaging the forest. Weighing 1,800 to 2,200 pounds, these horses pull heavy logs using harnesses that evenly spread force. Skidding routes are carefully planned to avoid soil damage and protect nearby trees. Unlike machines, horses move gently, preventing root and soil disruption. Forests logged this way recover up to 40% faster, making it a more sustainable method of timber harvesting. Manual forge bellows and welding. Amish blacksmiths use hand-operated leather and wood bellows to maintain the high heat needed for forging metal without electricity. The dual-chamber design provides steady airflow by alternating compression and expansion, reaching temperatures of 2,000 to 2,500 degrees Fahrenheit. This allows forge welding, where heated metal pieces are hammered together while still soft. Amish blacksmiths craft durable items like hinges, latches, and bolts that often outlast factory-made hardware, even after decades of exposure. Wooden peg joinery. Amish builders create strong wood joints using only wooden pegs and precisely drilled holes. This method uses wood's natural expansion and contraction to strengthen connections over time. Pegs are carved slightly larger than the holes and driven in with force, forming tight, lasting bonds. Seasonal humidity changes cause both peg and wood to expand or shrink together, keeping joints secure. These joints often outperform modern fasteners, with Amish furniture lasting for centuries and nearly impossible to take apart without damaging the wood. Hand-cut mortise and tenon. Amish craftsmen create mortise and tenon joints that form strong, load-bearing connections without metal fasteners. The tenon fits precisely into a mortise cut with extreme accuracy. Tiny gaps can weaken the joint. These joints distribute stress evenly, resisting both compression and tension while allowing slight movement to prevent splitting. Done properly, they often outlast the wood itself, staying tight and solid even as the timber weathers and ages. Manual trusses and rafter cutting. Amish builders frame roofs with hand tools, using precise templates to cut each rafter for consistent pitch and strength. The first rafter becomes the master pattern, checked carefully before guiding all others. Even small errors can cause major misalignment, so accuracy is critical. Amish craftsmen learn this skill young, starting with simple roofs and advancing to complex barns. They apply traditional math to calculate rise and run, ensuring proper drainage and snow load support. Their hand-cut rafters often match or exceed machine-made precision. Board and batten siding. This time-tested siding method combines wide vertical boards with narrow covering strips called battens, creating weather-resistant exterior walls that naturally adapt to seasonal temperature and humidity changes. The Amish have refined this technique over generations to provide maximum protection while minimizing material waste and maintenance. Installation begins by attaching wide boards, typically 8 to 12 inches across, directly to the building frame using hand-forged nails driven at precise intervals. Small gaps between boards are intentional, allowing wood to expand and contract without splitting or warping. Battens, usually 2 to 3 inches wide, cover these gaps and overlap board edges to form a weatherproof seal. The vertical orientation sheds water better than horizontal siding, preventing moisture buildup that can lead to rot. This overlapping system also blocks wind-driven rain from entering, even during storms. Amish buildings using this method have withstood decades of harsh weather with minimal upkeep, proving the long-term value of traditional craftsmanship. Individual boards can be replaced without disturbing the entire wall, making maintenance simple and cost-effective for generations. Lime plastering. Creating smooth, durable interior walls with lime plaster is one of the most sustainable and health-conscious finishing techniques used by traditional builders. This ancient method produces breathable surfaces that resist mold, mildew, and moisture damage far more effectively than modern synthetic materials, which often trap humidity and lead to health issues. The lime plaster mix consists of just 3 core ingredients: aged lime putty, clean sand, and water, combined in precisely measured ratios. The lime putty is made by heating limestone in traditional kilns to produce quicklime, which is then carefully slaked with water and allowed to age in covered pits for several months. This aging process yields a smooth, workable substance that gains quality over time, increasing in plasticity and ease of use. Application technique plays a critical role in the longevity and finish of lime plaster walls. The material must be applied quickly before it starts to set, in thin, even layers that are smooth to avoid cracking as it cures. Amish lime plaster is so refined and durable that modern drywall can't compete. Applying multiple thin coats creates a strong bond between layers, forming a unified, long-lasting surface. Over time, the plaster continues to harden as it naturally absorbs carbon dioxide from the air, eventually transforming back into stone-like material through carbonation, making walls that get stronger with age. Straw bale insulation. Densely packed straw bales inserted into wall frames form one of the most efficient natural insulation methods ever developed. The Amish first noticed this when older barns with straw-filled walls remained surprisingly warm during harsh winters. What began as improvised storage turned into a purposeful building technique that often outperforms modern insulation. The secret lies in tight compression and protection from moisture. Straw bales must be compacted so firmly that no air can flow through them, preventing convection currents that would otherwise transfer heat. Each bale is compressed to nearly half its original thickness and then locked into place. This dense packing creates thousands of tiny air pockets that trap warmth while maintaining structural stability. Many are surprised to learn that straw bales, when compressed correctly, are also highly fire-resistant. Unlike wood framing, they contain very little oxygen, making combustion difficult. In fire tests, straw bale walls have resisted flames for more than 2 hours before any structural compromise. The surface layer chars and creates a barrier that prevents fire from penetrating deeper. When combined with lime plaster, these walls form fire-resistant barriers that have helped preserve Amish buildings even when nearby structures were lost to flames. Horse-powered sawmills. Transforming raw logs into lumber without the use of electricity takes mechanical skill the Amish have refined over generations. Horse-powered sawmills operate using a central gear mechanism driven by one or more horses walking in a circular path. This movement turns gears that convert the horse's steady pace into the high rotational speed required to power the saw blade. With the correct gear setup, a horse walking at just 3 miles per hour can drive the blade at speeds over 1,000 RPM. These systems also include mechanical governors that stabilize blade speed despite variations in cutting resistance, allowing for smooth, accurate sawing through various wood types. Amish sawmill horses are so dependable, they might as well ask for benefits and time off. These mills can handle logs up to 30 inches thick and 20 feet long, producing enough lumber to support entire communities. The blades, generally between 4 and 6 feet in diameter, cut with accuracy comparable to modern band saws, without generating pollution or noise issues. During busy seasons, multiple horses can rotate in shifts to keep the operation running non-stop. Since their only fuel is homegrown hay and oats, this system remains entirely off-grid and self-reliant. Sledge and wedge splitting. Manually splitting logs into consistent posts and firewood is one of the most physically demanding yet vital skills in traditional construction. The method depends on precise coordination between the placement of the wedge and the force of the sledgehammer to produce clean splits that follow the wood's natural grain without wasting material. Correct wedge positioning is critical to successful splitting. It must be aligned with the wood's natural stress lines, often visible as small cracks or grain patterns at the log's ends. A poorly positioned wedge can get stuck or result in uneven splits that ruin usable sections. Experienced splitters can read the wood, identifying these internal stress indicators to guide their placement. The physical part of the task demands both strength and accuracy. The sledgehammer must hit the wedge squarely to apply full force, while avoiding off-angle hits that could damage tools or cause injury. With each blow, the wedge penetrates deeper until the wood yields and splits cleanly along its grain. A seasoned Amish woodworker can divide a 16-inch log into 8 evenly sized pieces in under 5 minutes, producing firewood or fence posts with the kind of uniformity that rivals machine-cut lumber. This speed and accuracy come from a deep understanding of wood grain behavior and precise force application. Hand crank drills. Accurate drilling without electricity is made possible through hand crank drills, which convert manual rotation into controlled cutting motion. These tools use gear systems to amplify hand movement into the high-speed rotations needed for efficient drilling, while giving the operator full control over pressure and speed. A side-mounted crank handle connects to internal gears that significantly boost rotational output. Varying gear ratios make it easy to adjust for different materials, slower speeds for hardwoods and faster speeds for softer woods. The chuck mechanism securely holds different bit sizes, enabling quick changes in hole diameter during construction. Because the rotation remains consistent, these drills avoid the bit jamming issues often caused by uneven electric drill operation. Users can immediately sense changes in resistance and adjust their pressure or speed to avoid overheating or breaking the bit. Hand crank drills are so reliable they make electric ones seem indecisive. They perform exceptionally well in tasks requiring accuracy over speed, such as joinery and fine woodworking. The Amish have relied on them for everything from drilling large timbers to detailed cabinet making, showing that human-powered tools, when paired with expertise, can match or surpass modern power tools in quality and control. Hand planing wood. Creating smooth, high-quality lumber surfaces without electric tools depends on mastering the use of a hand plane, a tool that can turn rough-cut boards into materials ready for fine woodworking. The Amish have refined hand planing to a level where it produces finishes better than those made by machines, while also enhancing the natural grain of the wood. The sharpness of the blade is the most critical element in successful planing. The plane iron must be finely honed and adjusted to the correct angle to produce thin, consistent shavings. A dull blade tears the wood fibers instead of slicing them, leading to uneven surfaces that take extra time to fix. Skilled workers sharpen their blades regularly, often daily, maintaining edges capable of shaving wood curls thinner than a sheet of paper. The technique requires smooth, overlapping strokes with steady pressure and blade alignment from start to finish. Each stroke removes a delicate layer, gradually exposing the wood's grain and producing a surface smooth enough for finishing without sanding. With proper posture and steady control, craftsmen can flatten and square boards to exact measurements, matching the accuracy of machine tools. The repetitive, flowing motion of hand planing becomes almost meditative, with the quiet sound of blade on wood and curling shavings offering a tactile experience machines can't match. Amish experts can plane boards with tolerances down to thousandths of an inch, demonstrating that skilled hands can rival even the most advanced equipment. Foundation stone laying by eye. The Amish have turned stone foundation laying into a craft that outshines modern construction. Using only string lines, wooden stakes, and inherited knowledge, they build foundations that often outlast concrete ones. Their secret isn't technology, it's a trained eye, developed through generations. Each stone is inspected like a gem before being placed. Builders study the grain, weight, and texture of every piece, understanding how it will fit with the rest. Stones are stacked so tightly that mortar is barely needed, forming joints that strengthen over time instead of weakening. What sets Amish stone foundations apart is their ability to handle ground shifts and environmental stress. Concrete often cracks under pressure or frost, but these foundations adapt. The stones support each other in a natural system that spreads weight evenly. Some Amish barns have stood on these hand-laid foundations for over 200 years, surviving earthquakes, floods, and frost that destroyed newer buildings. The secret is letting each stone find its natural resting place. Manual site leveling. Amish builders level uneven ground using only shovels, rakes, and teamwork, no machines. They place wooden stakes with string lines to guide elevation and shift soil by hand, ensuring proper drainage. Though slower, this method offers greater precision and avoids soil compaction. It also helps spot drainage issues and unstable areas that machines might miss. The result is a stable, long-lasting foundation that often outperforms machine-leveled sites. Rope winch pull systems. Amish builders move heavy beams and stones using rope winch systems, simple devices that multiply human strength through basic mechanics. A hand-cranked drum winds rope to lift or pull tons of weight with precision. Larger drums and longer crank arms increase force, allowing teams to move massive loads without engines. Unlike modern machines, winches offer instant control and pinpoint accuracy, especially vital when fitting large beams. They require no fuel, don't break down, and rely only on rope, wood, and teamwork. Block and tackle systems. Amish builders use pulley setups to lift heavy timber and roofing materials with ease and precision. By arranging multiple pulleys, they reduce lifting effort by up to 75%, using basic mechanical advantage. A two-pulley setup halves the effort, more pulleys reduce it even further. These systems require longer rope lengths and strong anchor points to handle redirected forces. Deep-set posts or stakes ensure stability. With this method, small crews can move heavy loads with accuracy that modern hoists often can't match. Lever-based lifts. Amish builders use long wooden beams and fulcrums to create lever systems that lift heavy materials without machines. By placing the fulcrum near the load, small crews can apply minimal force to lift large objects. They choose strong, straight-grained wood like oak or ash to prevent bending or breaking. Multiple levers, used in sync, can raise walls or rotate beams with precision. This method relies on teamwork, communication, and real-time adjustments, offering flexibility that machines can't match. Chalkline snapping. The Amish use chalkline snapping to create straight reference lines without lasers. A string coated with chalk powder is stretched tightly between 2 points. One person holds it, while the other snaps it against the surface, leaving a clean, straight line. It's used for marking joists, cuts, and layouts. Different chalk colors serve specific purposes: blue for temporary, red for permanent, and white for dark surfaces. This method remains highly accurate, even outperforming laser levels in bright or dusty conditions. Foot-powered table saws. Amish craftsmen use foot-powered table saws that convert pedaling motion into blade rotation. A flywheel stores energy, delivering steady power through belts and pulleys. The operator controls speed and torque with foot pedals, adjusting for material type. These saws offer precise, smooth cuts without electricity, matching the accuracy of modern saws. They handle ripping, cross-cutting, and joinery work, all powered by human energy alone. Manual cement mixers. The Amish use hand-cranked or horse-powered barrel mixers to make concrete without electricity. The rotating barrel, set at an angle, tumbles cement, sand, gravel, and water while internal baffles ensure thorough mixing. Dry ingredients go in first, with water added gradually. Manual control prevents overmixing and allows real-time adjustments for perfect consistency. Horse-powered models handle larger batches at an ideal pace. These mixers often produce higher quality concrete than electric ones, thanks to the operator's careful attention. Ice block cooling systems. The Amish preserve food without refrigeration by storing ice in insulated underground chambers. In winter, they harvest 100 to 200 pounds blocks from frozen ponds using special tools. The ice is packed in sawdust or straw to slow melting and stored in chambers with drainage and ventilation to maintain cold air. Properly managed, these blocks stay frozen for 6 to 8 months, cooling root cellars and food storage areas. These systems provide stable temperatures, often better for preserving food than modern fridges. Gravity-fed rainwater systems. The Amish collect rainwater from rooftops, storing it in elevated tanks that use gravity for water distribution, no pumps needed. Gutters and downspouts are angled to direct water efficiently, with first flush diverters removing debris. Tank height controls pressure, every foot adds 0.43 psi. A 20-foot tank provides enough pressure for daily use, 40 feet matches city systems. Proper pipe sizing ensures steady flow. These systems reliably supply water for household, livestock, and construction needs, even during outages or droughts. The Amish may not use electricity, but their building techniques are full of power in simplicity, precision, and tradition. These timeless methods aren't just about saving energy, they're about doing things right. So whether you're building by hand or just want to build better, these hacks show that sometimes, old school really is genius.